unit is oxidation numbers. And oxidation numbers tell us the most likely charge an atom is going to get to achieve a full valence shell. And another way to put this is, what is the atom going to do with its electrons? So the easiest way to tell is that they match just like valence electrons with the period, or excuse me, with the column. So everybody in this column has a +1. Here it's +2, +3 over here. And then with carbon, it gets a little strange. Carbon can go either way. It's either plus or -4. And it's kind of like we go up the hill and then down the hill. So over here, nitrogen is -3, -2, then fluorine is -1, and the halogens have oxidation numbers of 0 because they don't do anything with their electrons. Now, this is the quick way to tell what you're going to do with your valence electrons, but what the heck does that mean? So let me show you over here with my sodium and my fluorine. Sodium, if you look on the periodic table, has an oxidation number of +1. Well, what does that mean? So here we go, let's look at this. We have a sodium here. He's got 2 electrons in this shell, and then 8 electrons in this shell, so that one's full. But then on the very outer shell, the valence shell, has just 1 electron. Now sodium, just like every other element, wants to have a full octet. It wants its outermost shell to be full. It can do 2 things. It can either gain electrons, or it can lose them. And so we're going to look and see what's easier for it to do. Would it be easier to gain 7 electrons, or would it be better or easier to just lose this one? Most of the time, sodium is just going to kick that one extra one off. And so its charge, it's now going to have 11. It's going to have 11 positives, but 10 negatives, giving it an overall net charge of +1. That's what the oxidation number means. So then let's look at fluorine. Fluorine is the same way here. It is just 1 electron away from achieving its goal of having a full octet. And so instead of losing all 7 of its valence electrons, it's much easier for it to just gain a new one, making it so that it has 10 electrons and 9 protons, giving it a net charge of -1, which happens to be its oxidation number. That's how oxidation numbers work.